Welcome back, Algebra 2. Today we're going to do 3.5, finding the zeros, which are also called solutions or roots of polynomials. So to find the roots of each polynomial, we are going to factor, and we need to set those factors equal to 0 and solve. So our first polynomial here is y equals 3x to the 5th plus 18x to the 4th plus 27x to the 3rd. So the first thing I'm going to look for is a greatest common factor. I have an x to the 3rd here that I can take out of all terms. So I'm left with 3x squared plus 18x plus 27. And looking at this, I can also take a 3 out of all terms. So I'm just going to go ahead and pull that 3 out. So that's x squared plus 6x plus 9. Now I'm going to factor this x squared plus 6x plus 9. And we're going to use our method of multiplying our a times c. So that's 9x squared. Find my factors of that add to 6 would be 3x and 3x. So because this is an x squared, I'm going to go on ahead and plug this back in, x squared plus 3x plus 3x plus 9. And I'm going to do my factor by grouping method. I'm going to group those and group those. And I wind up with x times x plus 3 and 3 times x plus 3. So my factor here is x plus 3 and x plus 3. And then I still have that 3x to the 3rd that I pulled out at the very beginning. Now I'm going to take all of these factors and set each of them equal to 0. So 3x to the 3rd equal to 0, x plus 3 equals 0, and x plus 3 equals 0. And I'm going to solve. So I'm going to divide both sides by 3, and I get x to the 3rd equals 0. Take the cube root of both sides, and I get x equals 0. X plus 3 equals 0. Subtract 3 from both sides, and I get x equals -3. And this one's the exact same thing. So I'm going to subtract 3 from both sides, and I get x equals -3. So my zeros here for my polynomial are x equals 0, -3, and -3. All right, let's go on ahead and take a look at this next one. Okay, so the next one here is x to the 4th minus 13x squared plus 36. Okay, so because this is a 4 and this is a 2, I can treat it just like a quadratic where it's a 2 and an x squared and then an x. I'm going to multiply my a times c, so I get 36x to the 4th. Now I need to find my factors that add to -13. Okay, so 1 times 36, and I'm skipping using the pluses and minuses, but I'm going to have some pluses and minuses here. 2 and 18, 3 and 12. 4 and 9, and 4 and 9 do add to 13, but I need to make sure it's a -13. So if I make that a -4 and a -9, that multiplies to positive 36 and adds to -13. So that's my pair. I'm going to replace this x to the 4th minus 4x squared minus 9x squared plus 36. And now I'm going to do my factor by grouping method. So I can pull an x squared out of here, and I'm left with x squared minus 4. And I can pull a -9 out here, and I'm left with x squared minus 4. So there's one of my factors, and there's my other factor. So x squared minus 9 and x squared minus 4. But I can factor both of those even more because they're both difference of squares. So that's going to become x minus 3 times x plus 3. And this one's going to become x minus 2 times x plus 2. So now I have to set every one of, I have to set every one of these factors equal to 0, and I have to solve. So x plus 3 equals 0, x minus 3 equals 0, x minus 2 equals 0, and x plus 2 equals 0. So I get x equals -3, 3, 2, and -2. And those are my answers. So we're finding zeros of polynomials, just like we found zeros of quadratics. Just now we're factoring a little bit differently. Okay? Sometimes we might have to use division, and sometimes we might have to just use factor by grouping. So you notice on this first problem that we did, we wound up with an x equals -3 and an x equals -3. Anytime we wind up with a root, we have a multiplicity. So a multiplicity occurs when a polynomial equation has a factor that appears more than one time. Okay? So what happens, this creates a multiple root. So the multiplicity of root r is the number of times that that factor is a root, okay, or it's a factor. When a real root has an even multiplicity, the graph will touch the axis, but will touch the x-axis, but will not cross it. When a real root has an odd multiplicity, the graph bends as it crosses the x-axis. So if we just have here, okay, at -3, this is like that one that we just did. Okay, so it had x plus 3 times x plus 3, which gave us the roots of x equals -3 twice. That meant it had a multiplicity of 2. So what that means is this graph is going to touch here on the x-axis, but then it just bounces off of it and goes back down. The root 0 has a multiplicity of 3 because really, when we took the cube root here, it was actually 0, 0, and 0, which means that the graph actually bends at 0, 0. So a multiplicity of 3 means it kind of turns like this and then goes up. Okay? If it's a multiplicity of 1, that's where it just goes straight through the x-axis. Okay, but usually you're going to see multiplicities of 1, 2, or 3. So keep that in mind because that's going to help us to graph functions. All right, so let's go ahead and graph 2 functions and then we will be done for today. So for each function, identify the end behavior, find the zeros, the y-intercept, and sketch the graph. Okay, so the first thing I'm going to look at here to find the end behavior, this is going to be an x squared because of that, and an x. So I'm going to have an x to the third, and my a value is -1. Okay, so it's an x to the third, so it's odd with an a less than 0. So my end behavior then means that it's going to start as x approaches -infinity, my y or my f of x approaches +infinity, and as x approaches +infinity, my y approaches -infinity. So now I need to find my zeros. So to find my zeros, I'm just going to set my x minus 1 equal to 0, but notice it's squared, so that's really x minus 1 times x minus 1. So that's going to be there twice. I don't know why I'm putting parentheses around it. And then x plus 2 equals 0 one time. So my x can equal 1, 1, or -2. So at -2, since it's a multiplicity of 1, it's going to cross it. Okay? And at 1, it's just going to bounce off. And then my y-intercept, I'm going to plug 0 in for x. And I get -1 times 0 minus 1 squared times 0 plus 2. So that's going to be -1 times 1 times 2, which gives me -2. So 0, -2 is my y-intercept. So now I can go on ahead and graph this. It's going to start up here. Okay. And at -2, it's going to bounce right through it. It's going to touch. Okay. It's going to bounce off of 1 and go back down. Okay. So it's got the correct end behavior. It crossed at -2. It bounced off at 1. All right, let's go on ahead and do the same thing for x to the 4th minus 16. So these right here are both perfect squares. So it's a difference of squares. So I get x squared and I get 4. All right, so now that's going to be an x squared minus 4 and an x squared plus 4. So this is to the 4th power and it's a positive a. So I know my end behavior is going to be up and up. So x squared minus 4 becomes x minus 2, x plus 2. All right, so I'm going to have, and then this is going to be x squared plus 4, okay, which is really x plus 2i and x minus 2i. Okay, so I'm going to set each of these equal to 0, and I get x equals 2, -2, negative 2i, and positive 2i. So those are my roots. Okay. And my only real ones are 2 and negative 2, and it's going to cross right through those. Okay. My y-intercept, I'm going to plug 0 in for x, and I get negative 16. So that's going to be way down here. Okay, so this is a parabola, okay, and it's going to come way down here. Okay, it's to the 4th power. So somewhere in here, it's going to have some doo-wops, but I don't know where. So just sketching the graph, I'm just going to sketch it like that. And to find the doo-wops, you could plug in, you know, the numbers 1 and negative 1. Okay, so let's go ahead and do that. So 1 to the 4th minus 16, as 1 minus 16 is negative 15. And negative 1 to the 4th is going to be the same. So that would be minus 15. So yeah, it's going to be some decimals in here somewhere where there's going to be some whoop-de-doos, so or some maxima and minima. Okay. So have a great day, and I will see you all next time.